Well, I'm bored, and I'm the teacher, so I'm just going to start this. So welcome back to Silicon Dojo, with orderless, gatekeeperless, free-to-end user, hands-on technology education that empowers you to do whatever the hell it is that you want to do. So I've been working a lot on our site over the past number of weeks. If you have not been there, it's silicondojo.com, and this is going to be the epicenter for everything. We use Wix. I love Wix. I'm currently a Wix fanboy, and what's amazing about Wix is I basically pay for this about $12 a month for this product, and it just has lots and lots of functions. So we're able to have events. So we have events that are scheduled on here. We have blogs, so old videos of classes are here. We have self-study program. So we're going to have a better one of these, but we're actually going to have on your own time self-study programs here. And we have office hours. So on Mondays, between 1 to 5 p.m. Eastern Time, they're 30 minutes, basically tech coaching sessions, so you can book something here and come and ask questions about your career, starting a business, all of those kinds of things. And the cool part is there's actually what's called a CRM solution, a customer relationship management solution, on the back end of this thing. And so it basically tracks how you use the site, so that when we do meetings or when we do things, I can very easily pull up your permanent record with the school, see what you've done, see previous notes and things like that, and get up to speed relatively quickly. So I'm very happy about this. So we started doing the office hours a couple of weeks, well, this was the first week we did the office hours. So we did 4 office hours this week. These are just going to keep going, again, Mondays, so you can book these now if you want to. And the new thing that we're doing is for our classes, so for this, before, when you clicked on the RSVP, these would always go to Meetup, so you would actually sign up at Meetup. Now, if you want to, when you click on the RSVP, it'll actually take you to an internal page here, and when you RSVP, again, it will get tracked to your permanent record, so you can see the progress that you've made, and again, when you interact with me, and especially as we grow, the institution of Silicon Dojo will be able to see the progress that you've made. Again, one of the big things I've been interested in for a long time, if you followed me, is the idea of institutional relationships, that the institution itself should have a relationship with the users of the institution, and I find Wix, their back end, is a very good first draft for that. So anyways, that's what's going on there. Again, I have been working on the self-paced class. So this is our Python series. It just keeps getting longer and longer and longer. And so the idea is there's all these different chapters and there's classes. So this is variables in Python. We have concatenation. So I do these videos, short videos, like a 5-minute Eli video. Anyways, it's a short video, plus all the notes and the code and the kind of stuff down here. So the idea is that you can study at your own pace, your own leisure, and if you want to just skip around, you can just do the classes that you want to do. So if you already know concatenation, you're like, I know concatenation, I don't want to learn it again. You can simply say, I completed the concatenation step, because I don't care, and let me go down to if-else statements, and now I will learn about if-else statements, right? So it's a nice little thing you can just flip through. Rod has his hands up. Rod, what's up?
Oh yeah, I was just curious, so I see this recorded, like, do you put it on YouTube, or like, I'm just curious, like, and like anything besides that, or, I'm just curious.
Yeah, so basically, so Zoom is just recording this as a crappy backup, but I have a 4K camera that's sitting right here, right beside this, so this gets recorded, and yeah, so I'm going to talk about that in a minute. It gets recorded, and it gets posted to the Eli, the computer guy channel for these particular classes, and so these are the classes that we've done recently. So yeah, these will get, this will get posted as a 4K class, either tonight or tomorrow morning.
Okay, just wondering.
Yeah, cool. Yes, and if you have questions, raise your hand. There we go. Let's see here. So anyways, so this is what I've been working on. Hopefully, maybe next week or the week after, we'll get this done. This is currently up to 43 modules. And as I do modules, I keep adding modules. So I don't know, I've finished 23 modules out of the 43 modules that are currently written, and I do believe there's going to be about 10 more. So this will be up and running in the next, I don't know, week or so, or two. We'll find out. I will say again, Silicon Dojo is free to the end user, but basically we get paid for their crowdfunding. There is a link for DonorBox here. If you click the link to DonorBox, you will be taken to this. If you would like to throw some money in, that would be ever so lovely. If you find these classes to be valuable and you want them to continue and you can throw some dollars in, please do. That's there. Yeah, all the classes, again, there's a 4K camera sitting right there. Generally, they get recorded and they get uploaded here. Sometimes the video on the 4K camera, something gets screwed up like it did for the last class, and that's where I used the Zoom video, which is not good. It exists. The Silicon Dojo classes do go to the Silicon Dojo YouTube channel, just so you know, if you want to take a look at them as we're writing them out. There, and yeah, I guess that's about what we've got until we get into our class today. So anyways, we're gonna have a class. It's gonna be a lot of talky-talky. It's gonna be a lot of talky-talky. So most of the time when I do classes, I have lots and lots and lots of notes. So I try to write out all of these notes so that you have a lot of information and you can write your own notes and you can use these to create your own classes and the whole 9 yards. It's been busy for the last couple of weeks. So we've had Christmas here and we've had New Year's here, and I've been doing all the classes for the self-study program, and I've been doing a lot of other things. So I basically just have a bit of an outline here, and we are just going to talk about all of this stuff today. Don't worry, it's still going to be a good class. Just, you know, we're just not going to have as many words behind me. So anyways, so this is an introduction to programming class. And so with the introduction to programming class, it's important to understand with this is not about a specific language. This is not about C#, PHP, Python, JavaScript, Java, COBOL, RGB, Perl. So many. There are so many programming languages out there. It is basically about the concept of programming and the skills that will be required for you to go out there and program. Again, for us here at Silicon Dojo, the core language we currently use is Python. We use Python because it's just a fabulous language, but it does what it does, and it also doesn't do a whole bunch of other things. And one of the important things to be thinking about whenever you decide on your programming language is basically, what problem do you want to solve for? And again, I've been doing videos now. I've been doing videos since 2009. You know, I got my birthday for YouTube a while ago. Literally over 15 years I've been doing YouTube videos, and into all that time I always get these questions. I get these questions from the students. They're like, Eli, what language should I learn? What technology should I learn? And then I ask them, what problem are you trying to solve for? They're like, no, Eli, you don't understand. I just want to know what language I should learn. I'm like, no, but what problem do you want to solve for? And then they get really frustrated because I'm being like arrogant or something. I'm like, no, but for the love of God, I just need to know what fucking problem you need to solve for. And then I can tell you what programming language might work out. I think this is one of the big problems we get into, especially with a lot of people, new people that are getting into the technology world, is again, why do so many people want to get into the technology world? Because they want money, and they want respect, and they want people to look up to them. Which is, that's adorable. That's adorable. That's the crap people who aren't in the tech world say. That's what they think we do. But the problem is, right, one of the big issues that we have right now with so many people that want to get in the technology world is they don't actually want to solve problems. They want money, and they want respect, and they want job security, and they want all this make-believe crap they think the tech world is about. They don't actually want to solve problems, which becomes an utter disaster when you're trying to get people into this field, because what we do is solve problems. We solve problems and then get paid for it. Problem is, you have people walk into this field and they don't really care about solving problems. It's a bit of a crap show. So one of the big things I want you to be thinking about, especially if you're new to technology, is basically, what problems do you care about? What problems do you want to solve? Because there are a zillion things to do in technology, quite literally, a zillion. maybe a zillion and a half things to do in technology. And so you got to figure out, you got to narrow that down into the area that you're actually concerned about. And so one of the big things to be thinking about for yourself is, again, what do you care about? What are you interested in? What problems do you want to solve? And worst case scenario, if you don't have that, go to your boss. Again, I'm gonna give some controversial advice. This is the kind of advice that just makes people angry. Go to your boss and say, "Boss, hey, what problems are valuable to you?" And then find out what your boss has to say. And then go figure out what technology will solve those particular problems. So again, that's the big thing. Again, I get a lot of people, what language should I learn? Whatever virtualization software I should learn or whatever else. And again, it comes down to what problems are you trying to solve? What do your customers want? What do your clients want? What does your boss want? What does your team need? And then after you get that information, then you go and you learn whatever the product is. So when we're talking about programming languages, right, one of the big things to be thinking about programming languages is that more or less, these are simply applications. They are applications that create other applications. So when we're thinking about the programming language, again, there are so many, so many programming languages. Python, PHP, Java, JavaScript has nothing to do with each other. C#, C, C++, Perl, all kinds of stuff, right? One of the things to understand with these programming languages is that they're designed to basically solve certain types of problems. Now, they can solve problems they're not designed for, but it is a bit of a disaster. The example that I try to give is with QuickBooks, you could write a term paper for school. I mean, you could, right? You can tippy-tap type. It's got a little spell check in there. You could write a 10-page term paper in QuickBooks. Nobody would be happy with that result, but theoretically you could, right? Same thing is true with programming languages, right? If you're trying to build something with a programming language, basically one of the big questions that you have to ask yourself is what problem are you trying to solve for, and does your language solve that particular issue? And so that's going to be one of the big things when you're looking at all these different languages out there. Again, just to narrow down. So again, Python. I love Python. I'm an old school systems guy, right? I got my MCSE back in NT 4.0 back in 2000. I was in the Army before that with systems type stuff. Again, systems is just my world. So one of the reasons that I love Python is a programming language that can connect to incredibly diverse systems, be able to pull information in, be able to send data out, and be able to create things that are actually useful. And thankfully it has relatively easy syntax to learn. So that's one of the reasons that I like Python. One of the things you're going to have to be thinking about is, again, in your particular environment, what do people care about? Again, it's like, Ruby on Rails versus PHP, if you go back to about 2015 timeframe, it was interesting. So PHP and Ruby on Rails, same, kind of sort of solves the exact same types of problems. What was interesting is PHP was highly in demand on the East Coast. If you were east of the Mississippi in the United States, people wanted PHP. If you were west of the Mississippi in the United States, people wanted Ruby on Rails. Why? Basically, the idea was Ruby on Rails was easier to learn and easier to code. PHP was more efficient with resources. But at the end of the day, really? Is that why half the country did one thing and half the country did the other? No, not really. But here's the deal. If you were in Baltimore, you would learn PHP, or you should learn PHP. If you're in Austin, Texas, you should learn Ruby on Rails. Basically, that's because it's what the market in that particular area wanted. When we start talking about the programming languages too, we're going to be talking about stacks. And so basically the stack is going to be all the technology that is required to make your program work. We'll get to Vladimir in a second. So we talk about the stack. Well, that's dead. Anyway, so when we talk about the stack, there we go. We're going to have a nice big stack here. And so when you think about, again, things like programming, Vladimir, go away. Anyways, one of the things to consider is that it's not simply the programming language itself that is going to create the finished product for you. It is going to be everything else included in that stack. So there used to be, or I guess there still is, something called the LAMP stack. So this stands for Linux, Apache, MySQL and PHP. So basically, you have your box. On that box has the OS operating system of Linux. It has an Apache web server. So the Apache web server is what presents a website or web application to you. You have PHP, which is that language. It's called an interpreted language that allows you to dynamically build websites for the end user. And then you have something called MySQL, and that is the database. It stores the records of data for your app, and you're able to retrieve, right? So if you have the LAMP stack, this is what we're talking about: Linux, Apache, PHP, and MySQL. So if you walk into an environment and you say, what does your stack look like? And they say LAMP, then you need to know Linux, Apache, PHP, and MySQL. And so, again, if somebody's asking or trying to figure out what programming language they should learn, then basically they should be learning PHP, and they should be learning this language called SQL, Structured Query Language, right? Because that is the stack that you're interacting with. But these stacks can be different. Again, there's a YouTube channel called Fireship, and about lost my mind with one of his videos. So back in the day with databases, again, database, MySQL, MariaDB, MongoDB, all these databases out there. Anyways, back in the day, back in 2010s, there were like 3 databases, right? There was MySQL, there was MS SQL, and there was Oracle. So depending upon the stack you were dealing with, you learned one of those database engines. The interesting thing is Fireship, this guy who does YouTube videos, he's a professional coder, does YouTube videos. Basically, he just did a video about a year ago that said that the video title was literally the 30 most popular database systems. That's not all the database systems. That's the 30 most popular ones. And so one of the things you need to be thinking about, again, when you start thinking about programming and all that kind of stuff, is what is the stack of all of the technologies going to look like? Again, we talk about this with Microsoft. So you'll hear about Microsoft, and basically Microsoft has their stack. There's Windows, as you guys probably know. Under Windows is something called Active Directory. There's a huge number of Windows services. And then they have their cloud architecture called Azure, right? So if you're going to be creating applications that are going to be for Windows, that are going to use Active Directory, that are most likely going to interact with something called MySQL, and then they're going to do all kinds of replication and all kinds of fancy crap up with Azure, then most likely the language that you're going to want to learn is a language called C#. C# is the language that was designed to focus on that particular architecture style, that particular stack. And so again, this is going to be one of those things to be considered, right? If you have a database and you want your language, whatever language you're learning, to be able to communicate with that database, one of the big questions that you're going to have to ask is what languages communicate with that database, right? If you pick a language that doesn't talk to this database, then that is not going to work. And so that's going to be one of those things to consider when you're playing around with this kind of thing and trying to figure out it's what problem are you trying to solve? So does my programming language that I'm picking solve the type of problem that I care about? So Swift is a programming language. Swift is what you use for the iOS, the Apple ecosystem. So if you're like, I want to create Android apps, don't learn Swift. Right? If you want to create iOS apps, learn Swift. And then as you're figuring like, okay, so this is what I'm going for, and again, then you start looking at that stack, and then with all these kinds of things, you figure out what programming language is important to you. Just to make sure he doesn't get lost in the cracks, Vladimir, can I help you with something?
Yeah, my question was about, I was going to ask you about the separation of popularity in Ruby on Rails and PHP, and I guess is that prevalent to this day? Could you please explain why that difference had happened?
Oh, okay. So with Ruby on Rails and PHP, I don't know why it was. I think a lot of it had to do with Oh, you had, so Ruby was the cooler, sexier language. Oh, well, so Ruby on Rails. Ruby is a programming language. Rails is something called a framework. We'll talk about that in a little bit. So that was kind of considered the newer, cooler, sexier programming language back in the early 2010s. PHP was kind of considered the older one that had been around for about a decade or so. And so I think one of the big things is it was easier to get coders up to speed with Ruby on Rails. So if you're dealing with startup companies, if you're dealing with new technology companies that frankly just need to get asses in seats and they need code deployed, you're probably going to pick a language that's easier for people to learn. Whereas in the East Coast, if you have more legacy companies, legacy places that have been around for a while, they also have legacy applications that they have to support. So it's probably more likely that they would want that older language because they already have the legacy applications that are already built in PHP, so in order to maintain it, you have to stay with that particular language, and they might not be so worried about trying to spin things up very quickly. But again, when you start thinking about things like, even now in the technology world, like Node.js, so all the cool kids love Node.js, but there's this language called C#. So when I was in the Baltimore area, last time I was up there, I was talking to my buddy who's a CIO, and he does government contracts, and he literally said, in like the DC area, as long as you can read those two frickin' characters, he would hire you to be a C# developer. Because one of the big problems that they have, again, this is like the weird psychology, right? Is you have applications that need to be supported, they need to be deployed, the whole 9 yards. One of the problems that you run into is the kids, right? Young people, they want to go and learn cool technologies, right? So Node.js is a cool for some reason, it's a cool technology. C# is not considered a cool technology. So one of the problems they had is and they still do, they have so many C# positions open, but everybody's learning Node instead. And it's just one of those things because they've got government, so they have the government. So government is heavily reliant on the Windows stack, the Microsoft stack. They have basically large contracting companies, again like Raytheon, Lockheed Martin, those types of things. They're heavily into the Microsoft stack, and so they need people to be able to build for that stack. So they need C# developers. People just don't want to learn C#. Again, I have a buddy of mine I talk about every once in a while who's a COBOL developer, and I've gone to meetups, and it's been hilarious. This guy's doing well. He is a young guy. He's doing well in life, and I've seen JavaScript developers try to browbeat him, and it's hilarious. It's like, aw, little JavaScript developer. You don't realize how in demand COBOL still is. But that's one of the problems we get into is, again, people get emotionally invested in these languages for some reason, and certain languages they consider cool, and certain languages they don't consider cool, and then that's one of the things that causes weird issues kind of with the employment market. So yeah, anyways, one of those things to think about. So we got, what is programming? We got stacks, and so let's talk about pseudocode. So pseudocode is going to be one of the first tools that you're going to use as you're trying to figure out what the hell language you need for the project that you're going to create. Basically, all pseudocode is where you sit there and basically you tippy-tap type, you write out code in truly human-readable format. So you're like, it's like, okay. You're going to sit down, you're going to start thinking about your code. You're like, okay, what do I want my code to do? What do I want my code to do? What am I doing? It's like, okay, so let's say I'm going to create an email news blast piece of software. So it's like, okay, what do I need to do? Okay, let's see. Get username and email from database. Right, so if we're going to be doing a news blast, so I'm going to go to a database, I'm going to go to something called a data store. I'm going to need to pull in information. I need to pull information from that database. So what information am I going to need? Let's say I'm going to need the username, I'm going to need the email address. So the username to say hi, and the email address to actually be able to send it out. So get username or name and email from database. Then I'm going to sit there, I'm like, okay, so now what I'm going to do? It's like, okay, so put those in list, let's say, or dictionary, or whatever, some kind of array. Maybe you want to say array Okay, that's a little technical. Okay, put in array. So I'm going to get this information from the database. I want to put it into an array. I want to put it into some kind of data type that's very, I can deal with. Okay, then once it's in the array, then what I'm going to do. Okay, loop, let's see, through array, let's see. You don't have to worry about the typing, right? This is just basically for you. So, okay, so then I put all those into the array, then I need to loop through the array, and then what am I going to do? So probably need to use like an email API, send email with username, with message, blah, 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 right? And so basically what we're talking about here, when we're talking about pseudocode, is right, you don't see a function here. There's no variables here, there's no lets or vars or dollar signs or anything else, there's no equals. Basically what you're doing here is in actually human readable format, or in you readable format. It doesn't even have to be human, it just has to be you. Right? What you're going to be doing with pseudocode is you're literally going to be writing out the steps of what you're going to try to accomplish basically with your program. Right? And so one of the things, and this is where we start talking about the programming language that you're going to use, is as you go through this, you're going to start filling in the blanks. Right? So you're going to say, send email with username with message. And you're like, okay, so when I'm going to send the email with that kind of stuff, right, who am I going to use? And there's an API service out there called SendGrid, right? So SendGrid, basically what you're able to do is with your code, you're able to connect to their service, and then you're going to be able to send an email out that way. And so one of the things you're going to need to do is you're going to need to think about this, and you're going to have to ask yourself, is what programming languages are able to connect with SendGrid to allow you to do this communication? And that's where you go. Then we go back to wherever here is. So we go here, basically the internet, and we go, okay, send grid API. Okay, so we can see the SendGrid API, and we go to here, and basically, you can say for free, use cases, features, and basically what you're going to try to go through here is figure out what programming languages you're able to use. And so, I don't know if you can see this. And so, god damn it. And so, right, featured libraries, we support your language. So there's something called curl, there's something called PHP, there's something called Java, Node, Go, C#, Ruby, or Python. So, since you want to use SendGrid for whatever reason, you then come here and you see which programming languages you can communicate with, to be able to send out an email with SendGrid, and then you start doing some more research here to narrow down to figure out the language that you're going to use. So here, you're writing this all out in you readable language so that you can then go do that type of research. And again, with a larger and larger program, you're going to do more and more of this research, and basically you are going to narrow down to a certain point where you're going to figure out what particular language you have to use. I think about this with Azure Cognitive Services. So Microsoft Stack, Azure, there's something called Cognitive Services, AI-like services. And they have this voice service that's really cool. But one of the weird things is, with the voice service, is you can use Python on an x86 processor in order to connect to the voice service in real time. But if you want to use an ARM processor, you have to use C#, right? So if I want to have Python code that connects to Azure with this, that's fine for speech services. If I want to use Python code to talk to Azure with this, it's not going to work. The only framework that would work is what's something called the .NET framework, so basically C# would work. And so basically it's literally that type of thing that you're looking at, is what kind of computer, what kind of hardware, what kind of system, and narrowing it down to figure out what language it is that you need. Let's see here. Which languages are more prone to AI takeover? Stop, please. Let me explain something to everybody out there. Y'all worried about AI. AI. Don't be worried about AI. AI? AI's a pansy. You know what you should be worried about? 7% interest rates. 7% interest rates is going to kill your job long before AI does. This whole thing with AI is marketing crap. It's marketing crap. Did you see? Because we've been told like VR, things like VR. We're told VR is going to take over the world. And did you see today that it appears that Apple has killed their Apple Vision Pro because nobody actually cares about VR? We are told about these products. We are told about these technologies, not because they're actually as revolutionary as we're led to believe, but because these big tech companies need more investment money. AI exists. AI is a thing. It's not that. 7% interest rate is going to kill your job long before AI does. Okay, now let's get to wireframing then. Let's see here. So basically what wireframing is, you can use software to do wireframing, all kinds of software, but Figma you can use to do wireframing. I used to use Photoshop back in the day to do wireframing. There's wireframing software out there, the whole 9 yards. Basically what wireframing is where you start thinking about what you want your application to look like. Right? So one of the big things to consider is whenever you go into a tech company, you'll notice there are whiteboards everywhere. Right? The walls are lined with whiteboards, and then people are still scribbling on the windows because there's not enough whiteboard space. And the reason is because 90% of your job is going to be planning, and 10% of your job is actually writing code. Again, that goes back to the whole AI thing. If you think the writing the code is what makes you valuable, you've missed the game already. That's not what makes you valuable as a professional. What makes you valuable as a professional is being able to plan all of this crap out before anybody actually starts writing code to verify not only that it will functionally work, but the users will actually be able to use the software, and it will also be maintainable going into the future. I think one of the hilarious things with AI right now is nobody's discussing maintainability. Can you imagine how much software is being created by AI right now that works perfectly? Functionally works fine. Great. In 5 years, when somebody has to upgrade that crap, how well is that going to work? Right? One of the things to be thinking about is planning. And so the important thing with that is where we get into wireframing. And basically all wireframing is, and again, you can do wireframing on a piece of paper, or you can do it with software. And all you're going to be doing is you're going to be drawing out, essentially, how your application should function. So generally when you're doing wireframing, this is going to be for anything that has like a graphical user interface. And so what you're going to do is you're just going to draw out your little pages here. Right? So, okay, so we're going to have a home page. And our home page, should have some kind of header that looks like something. And in that home page, there should be some menus right there. And in the home page, let's say if somebody wants to have a new service, let's say this is like a service order company. Let's say if they want a new service, we'll put a block there for new service. And let's say if they want to check on a service that they've already ordered, we'll have a check on order service there. And let's say under this, we'll have something like jobs. And then look, there's no CSS here, there's no HTML, there's nothing else. We're just scribbling out, what the hell should this look like? And so then we say, okay, so when somebody clicks this, and for a new service, it should then go to the new page. And they start thinking, what should the new page look like? Well, okay, so we probably need, what their name is, and we probably need what their address is, we probably need what their email is, and we probably need what their phone number is, and then they need like a description of what the problem is. And then the cool thing about wireframing, again, you can literally do it this quick. You can do it this quick. And then what you can do is you can take your little piece of paper, you can take your little wireframe that you've written this out on, and then you can go to your receptionist, you can go to your secretary, you can go to your installer and say, look, so this is what the input for a new service call is going to look like. Do you see any issues here? Should we ask for more information, or is there a reason we shouldn't ask for some of this information? And then you go to 10 of your installers or 10 of your people, and they say, yes, it looks good, or fix a couple of these things. I'm like, okay. Right? Think about that. That is so easy. Then there's going to be a little submit button there. And when they do the submit button, then the thing you have to think about is, okay, well, when you submit, what should happen? What does that look like? So you come down here in the submit button and say, you submit, work order, and then you draw out the other page and you say, okay, thank you, user, and then this information, and then maybe a map, this is where we think you are, and some other information for the service call or whatever else, and you get that information. And then you can take this, you can take it to your customers or whatever, and say, would you be comfortable with this? Does this look appropriate, right? And people say yay or nay, and then you're able to adjust it here. Then again, like I say, if it's something like, check your order or whatever, right? That would go to a check page. In the check page, okay, what kind of information do people want to verify, right? So maybe it's like a last name and an address or something like that, or an order number. So they plug that information in, they hit submit. That then goes down to a page for check your order. And that has whatever information there. And this is basically what we're talking about. We're talking about wireframing, is basically very quickly sitting here and designing out what the look and what the flow of your app is approximately going to be, so that you can start getting buy-in from the users. Again, one of the big things, like there's this idea in the modern world that coders are like these siloed individual, like lone wolves or whatever. And again, 25 years ago maybe, but not really in the real world. Most coders I know do so many meetings. So many meetings. Oh, they're having like 2 meetings a day. That would drive me up the wall. And the reason you have so many meetings is because you want to make sure you get buy-in from all the vested parties on that this is more or less how everything should work, so that when you sit down to actually go out and code all of this, you're not coding a lot of stuff that's going to end up going in the trash. Now again, you can do this on paper or whatever else and just flip through is an easy way to do it. With other products out there, simple products out there, again, you can use word processors, Google Docs or whatever, so you could actually have links. So basically, you could have this be a hyperlink that basically just takes you to a form that already has like kind of pre-filled out information. So this can be a hyperlink. This can be a hyperlink. This is all just kind of static crap, just to kind of give you the flow of how this works. So you can do that with kind of like simple wireframing software. I think things like Figma and that can do that too. If you do things like Virtual Studio? So Virtual Studio, one of the cool things with Virtual Studio is they actually have a graphical component built into it where you can actually design all of this kind of stuff relatively easily. You can do the wireframing, and then once somebody gives you the go-ahead, you can actually just put all the code essentially behind the wireframe and move forward that way. It's one of the reasons why Virtual Studio or Visual Studio costs a little bit of money at this point, but there's a lot of different options out there for things like wireframing. So this is one of the things you're going to be doing. One of the other things to consider with when you're going to be creating your programs is the idea of rapid development and basically rapid prototyping. So again, you don't want to spend an insane amount of time building something nobody wants to use. Right? That's worthless, right? You've only got so much money, you've only got so much time. So one of the things you can think about is kind of like what we're doing with Silicon Dojo right now, is again, at the end of the day, maybe 5 years from now, Silicon Dojo succeeds, we'll actually write a real custom engine to drive Silicon Dojo. But one of the nice things with like Silicon Dojo right now, like using Wix, is for if you pay $36 a month, you get all the functionality out of Wix for $36. Right? So think about this. A coder, or you, is going to cost a minimum of $150 an hour. If you contract a coder, you're looking at between $100 to $250 per hour for a coder. Right? So when you're first trying to figure out what the hell you want your app to do, what the basic flow of the app should be, all of that kind of thing, do you really want to be spending $200 an hour or whatever else for a coder to do this like really high quality? Or do you want to use some kind of product that will allow you to rapidly develop and rapidly prototype a product to start seeing if anybody cares that it actually exists? Again, this is where you can use something like WordPress. Again, WordPress for some reason nowadays is considered a bad word, though to be clear, the WordPress community has got off the deep end. Oh, I do not know what's going on with the WordPress community. But if you take the community out of it, or I guess you take the CEO of Automatic out of it, that's its own disaster. And you just look at WordPress as a product. Like one of the cool things about WordPress, right? It's got the database, it's got a whole bunch of stuff already built into it. There's a lot of ways you can build templates for WordPress relatively quickly. So you can use something like WordPress to rapidly get something off the ground. It may be clunky as hell, it may be ugly as hell, it may be slow as hell, but if you can actually build something relatively quickly, imagine being able to build something in a day. Not 100 hours, not 1,000 hours, not 50 people working on it for a year. If you can get something up and running in a day or two, and then start being able to put that in front of people's faces and say, what about this interests you? What about this turns you off? Would you pay $5 if this thing actually worked worth a damn? That type of thing. That can be incredibly valuable. So one of the things you want to take a look at is, again, in whatever world with programming that you're going to be in, the whole concept of rapid development. Like what can you use to rapidly come up with prototypes to get to the point where you can actually get some validation that anybody cares what it is that you're doing. What about Joomla instead of WordPress? I hate Joomla, and I cannot lie. I don't know if you like Joomla, use Joomla. I hate Joomla with a passion. I don't know who built Joomla. Joomla is just a disaster. Don't bring up Joomla. I'm having PTSD from Joomla. I had to deal with Joomla back in the day. Oh, it was bad. It was bad. Okay, anyway, so we start talking about languages themselves. So again, we got a zillion different languages out there, all kinds of different languages. You're going to hear about the concept of compiled languages versus interpreted languages. And this is going to be a big thing for you to consider. So basically what a compiled language is. So a compiled language is C, C++, I don't know, probably a whole bunch of others out there. Basically, the idea is you write your code. So your code is essentially going to be text. You're going to write it in something called an IDE. VS Code is an IDE, an integrated development environment. You're going to have that code, and then at the end of it, if it's going to get compiled, you take all of that text, you shove it through something called a compiler, and out the other side becomes something that's written in machine language. When we talk about machine language, what does that mean? Basically, it means that the operating system is able to interact with that program that you have created, and it is generally its own individual file. So if you're using a Windows machine and you see a .exe file, that was generally created by something that was put through a compiler, and you get that .exe file that the operating system is able to run on its own. So the operating system is able to run it. You don't need anything else as long as it was compiled correctly. An interpreted language, and when we talk about interpreted languages, this is most of them you hear about today. Node, JavaScript, Python, PHP, Perl. Probably don't know what Perl is, but anyways. Basically what the interpreted language is you actually have a piece of software that needs to be installed on the computer itself. So Python, right? So we use Python 3 in Silicon Dojo. They're up to what? Python 3.12.7, I think is the current version. Basically, that is actually a piece of software. In order to run Python code on your machine, you actually have to have the Python interpreter installed. And so what happens is when you trigger that script to run, the interpreter is going to read that file that you created, and it is going to turn it into a program. So again, if you're talking about Python, especially with frameworks, that can be everything from scanning through a database or a file to pull out information to actually being able to come up with a graphical user interface. So there's something called tkinter that allows you to create graphical user interfaces with Python. You can create web applications with Python, the whole 9 yards, but you need an interpreter that's actually installed on the system for that to run. The nice part about interpreted languages is as long as the interpreter is installed on the machine, the script should be able to run properly. So if you install the Python interpreter on a Linux machine, on a Mac machine, on a Windows machine, different versions of those operating systems, if you have a Python script that gets triggered, it should be able to run okay. You generally, sort of. Generally, you don't have to modify the code a lot, whether it's going to be running on Linux or whether it's going to be running on Mac or it's going to be running on Windows. One of the big things to understand, though, is when you're dealing with compiled languages, this is going to get compiled for the operating system that you specify. So it'll get compiled for Linux, it'll get compiled for Windows, it'll get compiled for Mac OS, right? And so what happens there is if you have an executable file, right? So if you created your application, you put it through a compiler, you created it for Windows, you cannot just take that Windows file and literally just dump it onto a Mac and have it run, because it was actually compiled for the operating system that it was supposed to run on. And so that's where we talk about porting. So if you've heard of ports of programs, basically what this is where a company creates a program for one operating system, they verify whether or not anybody cares about it, and then essentially they create an identical version for a different operating system, run it through a compiler to create that version for the different operating system. So this was a big thing with QuickBooks back in the day. So with QuickBooks on Windows, they had like 12 versions. So back when I had my computer shop, my computer repair shop, we'd have customers and they'd need QuickBooks, and so on Windows there'd be like 12 versions of QuickBooks, right? There was QuickBooks and QuickBooks Pro and construction person QuickBooks and retail QuickBooks and nonprofit QuickBooks and all kinds of QuickBooks, right? Then you went over to Mac because people were like, oh, Eli, I've heard Mac is great. So as a CEO of a company, I want the best computer. So we'd set up a Mac for him. We'd build them. We'd build them for setting up a Mac. And then like, okay, now I need QuickBooks for Construction installed on it. And again, this was back in 2008, 2009, and it was like, well, you can't do that. Why? Because they don't create that version for Mac. They did not port a version of that to Mac, ergo, you get QuickBooks Premiere or whatever, and that's it. And so that's going to be one of the things to be considering, again, between compiled and interpreted languages. Basically, when you throw the code through a compiler, it'll be created for that one specific operating system. The idea here is, theoretically, that a compiled program should be faster and more reliable than an interpreted language. Why I put quotes around that, though, is again, time moves on. Time moves on, right? When I got my MCSE and my NT 4.0 back in 2000, I swear to you, the servers I dealt with were not as powerful as this thing. Right? So, again, when you're dealing with servers with 64 megs of RAM, servers with 64 megs of RAM, right? Things like the speed between a compiled language and interpreted languages really mattered. We are now in 2025, can you believe that? Where your smartphone has 8 gigs of RAM in the smartphone. And so one of the questions between this is it actually worth it to deal with the whole compiled languages at this point? Yes, compiled languages may be faster, they may be theoretically more resilient or reliable, but what does that margin actually mean, especially within your particular environment? Again, we talk about this thing at scale, right? So if you go into your company and you have a company that has 20 employees and you have a server that's running your script, this doesn't matter. This doesn't matter. Right? Now again, but we talk about scale. What if you go to Travelocity, or what if you go to eBay? What if you go to some place that's doing 2 million transactions a day? Right? The difference in speed and reliability when a company's doing 2 million transactions a day might actually matter a lot, whereas in a company with 20 employees or a little social app that you created that gets 10,000 views per day, it doesn't matter. So that's one of those things to consider too. Again, this is going to be a big thing in the technology world, especially the coding world. You're going to hear a lot of people scream about that, again, with like speed And again, you really have to think about what is your particular environment on whether or not that actually matters. You will hear about Java and C#. So these are compiled languages that are slightly different. They're actually kind of curious. So Java was really popular back in about 2000. Then it disappeared. Then it kind of came back. I don't know. Is it here or back again? I don't know. It's one of those things. It kind of comes and it goes. The idea with Java, right, is again, you had Macs, you had Windows computers, you started to have a little bit of Linux computer out there. And the problem is people, again, wanted to create code that they could just deploy anywhere. But the issue is, again, different operating systems, the whole 9 yards. One of the interesting things with Java and then with C# is basically Java came up with this idea of a Java virtual machine. And basically the concept is you know, you have these different operating systems, right? So you have Windows, and you have Linux, and you have Mac, right? And you've got the different computers here. They got different resources. They got different ways of doing everything, the whole 9 yards. And so what they thought about with Java is, hey, what if we just create this Java virtual machine? So the Java folks, they will create code that will be able to communicate with the underlying operating system. And then you can write your code to then interact with the Java virtual machine. So basically, again, the idea is that this point for the computer remains the same. So you can create a piece of software that'll work on Windows, will work on Linux, will work on Mac. All you have to worry about is making it compatible with the virtual machine. You don't have to worry about the underlying operating system. And that's one of the reasons Java was really popular, again, 20 years ago, was basically this idea, again, back then, of write once and being able to run anywhere. C# uses something called the .NET framework. It's Microsoft's essentially version of the same concept, and you will see .NET around a lot, again, especially if you're dealing with the Microsoft world. And so again, this is kind of one of those things to consider with what programming language you want to learn. Let's see here. You will hear about native apps. So basically native applications. This is going to be for your mobile devices, so iOS or Android devices. When you hear about a native app, this means an application that actually gets installed directly onto that smartphone. That smartphone, the tablet, whatever else, that is what you call a native app. The thing is, again, with those native apps, we go back to the bad old world of you need different programming languages to program for different environments, right? So iOS uses the Swift programming language. Android, it's right, Java. I do think they actually use Java or some variation of Java. And so those are two entirely different things, right? So you're sitting there, you're trying to figure out, like, what programming language should I learn? It's like, do you want to build things for Android, or do you want to build things for iOS? And again, weird things to consider. So Android, there are more Android phones in the world than there are iOS phones. So when you first hear that, you're like, oh, I want to be an Android developer. You're like, okay, well, here's a curious thing. Android phones, many times, are dirt cheap, right? You can buy an Android phone for $100, whereas iOS devices are incredibly expensive. It might cost you $1,500 for an Apple iPhone. Curiously enough, people who run iOS devices are more likely to buy apps, to actually pay for apps, than Android users are. So again, it gets to be one of those things of the app that you're going to be trying to create. Are you going to create an app that you just want users to use for some reason, and you kind of make money in some kind of way, right? That might be good for Android. On the other hand, if you want to charge people $5 an install or $5 a month, it might be better to go with a user base that's much smaller, but also much more likely to pay you money. I think about this with Barnes & Noble had a tablet. I think it was called the Nook. I do believe it was called the Nook. It was actually a pretty nice tablet. It just failed miserably. Anyways, it was interesting. I actually knew a couple who ran a development company, and they developed apps for the Nook. And it was kind of interesting. So I sat there and I talked with them. And again, they had like, why? What? The Nook never took off. There was never a time where anybody thought the Nook was going to like replace the iPad. But anyways, the interesting thing they said is like, well, because it's not going to take off, because no coder takes it seriously, nobody develops apps for the Nook. So basically what they said is you had all those parents out there that didn't know the difference between an iPad and a Nook. They would buy their kids Nooks. They would take it home. Their kid would want to play an educational game or whatever else. Nobody developed apps for the damn thing. So they were one of the few companies that actually developed apps for it. And so they made a crap ton of money selling apps on a pretty crappy tablet because they were the only ones to do it. Again, weird things to consider in the real world. So again, native apps, that's going to be, again, like I say, for the Android world, for the iOS world, that type of deal. You do have multi-platform frameworks. So you will hear things like React Native is something called a framework, or you may hear Flutter. So React Native came from Facebook. Flutter comes from Google. Now, I will complain a lot about Facebook. I hate Meta in many, 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 many ways. The consumer side of Meta is a crap show, is an evil, 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 evil crap show. But to caveat that, Meta is very nice to developers. Meta puts out some shockingly good products for developers that are generally free to the end user. Again, React Native comes from Meta. They developed this framework, and it's a framework that allows you essentially to write once, and then it'll spit out versions of your app, both for Android and for iOS devices. So especially if you have a relatively simple app, you can simply use React Native, you build the app, you test the app, then you can spit out, it'll spit out the code base for Android, it'll spit out the code base for iOS, it'll actually spit out the code base for Mac OS and Windows at this point, and then you can send those to the different app stores, and basically the idea is you can code it once. So you don't have to worry about Swift or Java. You can use React Native, or you could use Flutter. Again, Flutter is Google's version. One of the things to be thinking about with these multi-platform frameworks, how well this works might be a little bit questionable. So if you're doing simple apps, if you're doing relatively simple apps, pushing and pulling data, communicating with APIs, that type of thing, these should be fine. I do know developers who just don't use these anymore. Basically what they found is once you start creating more complicated pieces of software, more complicated apps, that essentially these are not refined enough, and you end up having to have either Swift or Java coders go in and fix all the bugs that React Native or Flutter create. And so that's going to be one of those things, is when you're thinking about what apps you're going to be creating, are they going to be relatively simple? We are going to create a news reading app where the user logs in and then they get a feed of all the news they want to read that day. Right? Oh. Right? One of these would probably work out. One of these is pretty fine. On the other hand, if it's like, we're going to create an app, and that app is going to communicate with an Apple Watch and a weight tracking thing and Samsung's watch and all this kind of stuff, and it's going to bring in all of this different data, it's going to process it in 50 different ways, it's going to send it off to a couple APIs and bring it back down. And if you're going to start doing something like really, really complicated, it might make more sense to just go with writing things in their own native, again, Swift or Java. Again, that's going to be one of those things you're going to have to play around with and think about what problem it is that you're trying to solve. Now, web apps. I love web apps. I love me some web apps. So what we're talking about with web apps. Web apps are web applications. Basically, you go to a website and you get a web app. So this is a web app. This is a web app, right? You get a video file, you get some documentation, I can say complete step. If I complete all my steps, you get to print out a fancy little certificate to say you completed all your steps. This is basically what a web app is. Again, any kind of SaaS, software as a service, is a web app. Salesforce is a web app. All of that kind of stuff. This is one thing to think about, is a lot of, especially startup founders, they want to go straight into iOS, or they want to go straight into Android, or straight into whatever else. When you do that, you're kind of locking yourself into that particular ecosystem, at least for a little bit of time, and it's going to cost a lot of money. One of the issues to be thinking about with this is, have you actually validated your concept with enough users? Have enough users actually said they care about your product one way or the other? Right? Because if you're going to go out there, again, especially you're going to hire a programmer, or you're going to be working with programmers or whatever else, right? Again, hundreds of dollars an hour, right? Pretty expensive. So do you necessarily want to dive directly into creating a Swift app? What happens if your company spends $100,000 to create a prototype of your app in Swift, and then you find out all of your users use Android? This happens in the real world. This happens in the real world. Wouldn't it be nice to test out your users beforehand? And that's a cool thing with web apps, right? With web apps, basically, again, you spin up your server, you have your stack, use Nginx, Apache, whatever else. You create your application, and anybody with a web browser can access it. If they have a Mac, they can access it. They have Windows, they can access it. They have Linux, they can access it. They have iOS, they have Android, they have Nook. Even if they've got a Nook, they can most likely still access your web app. And again, depending on the actual functionality of your web app, they should be able to get a lot of the things that you're trying to show them that your product will be offering. And one of the cool things is when you do with the web app, again, you don't have to deal with stores. So you're not going through the approval process, you're not going through the fee process or anything else. You don't have to worry about Apple being weird that day and not approving your product. You don't have to do any of that kind of stuff. You don't have to worry about the porting. All this stuff can be built with HTML, CSS, Python, the whole normal web app programming stack. And then when users are using your app, on the back end, you can actually log all the statistics, and you can log things like user agent. Right? What browser do people look at my app with? What operating system did people look at my app with? Where in the world? Again, what countries, what cities were they using my app from? And you can gather all of that information with a web app in a relatively fast order, relatively quick order, so that you can figure out what your next steps should be. Again, so if you're sitting there and you build your app, again, one of the things in the technology world is how your product gets utilized. It's gonna blow your mind, right? You're gonna walk in, you're gonna have this idea for a startup company or whatever else. You have this idea of how people are gonna use your product, and then they're gonna do something completely different. Like, I think about this, like with me doing videos, with me doing education videos, Everyman IT, all of this stuff. If you go way back when, and do you realize, like for me, back in 2012, over 50% of my students were Indian. What? like now it's 2025, I'm used to all this stuff. I'm like, yeah, sure, of course. But again, like for me, I'm just a little American sitting in Reisterstown, Baltimore, creating, on-demand education for the tech field. I had no freaking clue that my major demographic would be the Indian subcontinent. Didn't even cross my mind. But again, even now, if you look at the stats for Silicon Dojo, again, like I can pull up the cities, and if you see the stats of Silicon Dojo, it's heavy in the east coast of the United States. It's pretty significant in Europe. It's pretty significant on the east coast of Africa, and then like the Indian subcontinent is just like this ball. And I'm like, I wouldn't have expected that. I would not have thought of that. And so that's one of the cool things with these web apps. You can get them up relatively quickly. You can start getting that information, and then based off of that information, you can start planning for how you want to try to move the ball forward going into the future. When we talk about things like web apps, there's what's called front-end programming languages and back-end programming languages. Basically what this means is you have your app. You have your app. You have the person on the computer over here, and you have your servers over here. So basically they're going to be using their web browser. Again, if it's a web app, in the web browser there is an interpreter called a JavaScript, or an engine. Anyways, basically their web browser can read a JavaScript. Your server can understand, Python or PHP or something else, something called a back-end programming language. So when we talk about front-end versus back-end, Basically, here's the thing. There's going to be communication that's going to go back and forth between the user and your server. Basically, the question is where you're designing your software to work from. All right, so JavaScript developers, so JavaScript, CSS, HTML, something called Tailwind, that kind of stuff. These are basically front-end developers, and they are building out the front end of the application, and that is actually going to be running on the user's system itself. So essentially text gets sent to the user. That text with JavaScript and all this kind of stuff gets turned into the application, and the user is looking at that. We talk about the back-end programming languages. Again, we talk about Ruby, we talk about PHP, probably C#, a whole bunch of other ones. These are basically running on your server, and these are the languages that are going to be interacting with the infrastructure. So they are going to be talking to something called a SQL server. Structured query language is going to be your database server. It's going to be talking to your data stores. So this is going to be a storage array. It's going to contain pictures and video files and all kinds of static files and that kind of thing. This is going to connect out to what are called APIs, application programming interfaces, to be able to push and pull data in for things like AI services and that type of deal. So when we talk about the front-end programming languages or the back-end programming languages, this is what we're talking about. Front-end is running on the user system. Back-end is going to be running on your server system. When we talk about full-stack engineers, the idea is that a full-stack engineer should be able to develop for all of this mess. They should be able to develop front end, they should be able to develop back end, and they should also understand how SQL and the operating system and all of that kind of stuff works. I would argue this is the future. I would argue this is the past. I would argue this is just what you should do. I don't really think there should be front end developers and back end developers. I think there should be full stack developers that happen to currently focus on JavaScript or happen to currently focus on Python. One of the things you have to think about, again, when we think about front end or back end, is if you are a front end developer, you do not build products. You create a component for somebody else's product. If you are a back end developer, you do not create products. You create a component for somebody else's product. If you are a full stack developer, you can actually build an entire product. And again, whether we're talking about the future of AI or we're talking about 7% interest rates, one of the things is if you can go to people and you can sell them solutions to their problems, they are likely to hire you and pay you money. If you say, I can do front end, that doesn't necessarily solve a person's problem. If you can say, I can do back end, doesn't necessarily solve anybody's problem. If you say, I can build you a work order system so that you can track all the plumbers in your plumbing company in near time with GPS or whatever else, that is something you get 20 grand for. And so again, it's one of those things to consider. So front end, back end, what's called full stack. We then get to frameworks. So frameworks are a biggie. So basically what frameworks are is, again, they're basically libraries of code. One of the big things in the technology world is copy and paste is your friend. If you want to reinvent the wheel, anyways, so many kids out there want to reinvent the wheel. Don't reinvent the wheel. That's what copy and paste is for, right? Basically, again, in the coding world, when people solve a problem, they write up the code, and then you basically copy and paste it. Right, so what frameworks are, again, when we talk about frameworks, that's React Native, that's Flutter. If you've been following along with Silicon Dojo, that's OpenCV for computer vision, or Bottle, which is a web app framework. There's Django as a web app framework. There's Tkinter, which is a graphical user interface framework. Basically what frameworks do is they're libraries of code that extend the capabilities of your programming language to do cool and new and fancy things. Again, so Python, right? If you take a look at Python code, it's just text. You're like, how do you turn this text into a web application? Well, you install something called Bottle or Django or MA and many other frameworks. And basically with that framework and your programming language, you're able to extend Python to be a web application. Right? Again, with tkinter, you can extend Python to be a graphical user interface, a desktop application. With OpenCV, computer vision, you can extend Python so that your Python script now can see the world. Right? That's basically what we're talking about with frameworks. The warning that I will give you with frameworks is that many times frameworks are actually 20 times more difficult than the underlying programming language that you learned. You sit there and you're like, wow, Python's easy. Oh, Python, man, it took me like a week to learn Python. This is great. I went through Eli's self-study course. I learned Python in a week. I'm a pro. And it's like, well, yeah, but you should probably bone up on a couple of frameworks before you go out there. Oh, okay. And then you start to learn Django. Oh, that's a damn disaster. We will have a series on Django. I love Django. To be clear, I love Django. Oh my God, that is a miserable framework to learn, especially with the documentation that Django gives you. Oh, that is a disaster. I gave myself a week. I gave myself 1 week to learn Django. Ended up taking about a damn month. It was like, what? So anyways, there's a whole bunch of frameworks out there, and again, this is where like we talk about JavaScript. JavaScript, again, is one of these languages. Basically, they created a framework called Node.js. And basically with Node.js, you can run JavaScript on the back end to do a lot of the functionality that Python or Ruby on Rails or whatever would normally do. So since people already know how to write in JavaScript, they said, hey, let's create a framework that allows you to use the JavaScript syntax to be able to do things on the back end. Again, that is a framework. And so that's going to be one of the things you need to consider too when you're thinking about learning these programming languages. It's not simply the language itself, but it's also things like the frameworks, the APIs, all of these other things, what will, again, solve the problems that you care about. APIs are going to be a big thing nowadays. So we are in the modern architectural world. As it used to be called service-oriented architecture, SOA. Nowadays it might be microservices architecture. I don't know. They come up with more words than I can keep track of. At a certain point, you just stop keeping track of the words. You're like, I get the point. I don't know what. Anyways, the idea is back in the day, you used to own your own servers. You had your own servers, right? So you had your web server, you had your SQL server, you had your data store, so wherever you stored your data, plus you had some other servers, and the idea is you owned all of this, right? So basically this was all generally within your own infrastructure, whether or not it was in your own building, it was within your own infrastructure, and you were responsible for everything. You were responsible for everything from the operating system to the configurations to whether or not the CPU fan died. And there's nothing more hilarious than your entire system being taken down because one CPU fan died. So people realized it was a bad idea. This kind of sucks. This isn't a great thing. So in the modern world, when I came up with the idea of SOA, service-oriented architecture, and we use what are called APIs, application programming interfaces. And so the idea is you have your server sitting somewhere, and you have code that's running on your server, and now you want to do something, but you don't want to spin up your own server. You don't want to build your own server. You don't worry about the CPU fans on your own server, all of that kind of thing. So let's say you want an AI service. You want an AI service. I want my computer to be smart, right? So OpenAI actually has an API, and we've had many classes on this. And so what you can do is you can have your Python script basically communicate with OpenAI servers, and it can send it a query, essentially. You can say, hey, I want to know the answer to this. I want to know how many chucks can a woodchuck chuck if a woodchuck could chuck wood, which is something I've sent OpenAI, and it gives you different responses. So you say, how many chucks? Dear OpenAI, answer me how many chucks. And so OpenAI will think about how many chucks, and then it will send back the answer to however many chucks. Right? So if you have something like a web app, right? So again, use the Bottle web app framework. So you have a user that is going to your site. It has a little, ask me a question box. They say, how many chucks? That then goes to your Python script. Your Python script then sends that question to the OpenAI's API. OpenAI API sends the response back, and then that goes out to your user. And so that's the idea with an API and the idea of service-oriented architecture. What if, on the other hand, again, you start getting complicated with this kind of thing, with APIs. What if you wanted an AI SMS text service? You'll get really cool. You want to start adding in all the letters, right? So, okay, so you're going to have a user here, and they're going to have a phone. They're going to have a smartphone, and they want to plug into their phone basically a text message that says how many chucks. So they want to send a question to 222-333-444. So basically what's going to happen here, this is going to go to a vendor called Twilio. So Twilio has an API that allows you to receive text messages. So they use something called a webhook. We'll talk about these in different classes. So you have your server up here. Basically, the question about how many chucks comes into Twilio. Twilio then, again, basically knows where it's supposed to go and sends the information up to your server. Your server then gets this question about how many chucks. It then sends that off to OpenAI to say how many chucks. OpenAI then sends the response back for how many chucks. That then goes back to Twilio to basically a different service in Twilio. So Twilio has multiple APIs. That service sends SMS messages out, and it will say the number of chucks, woodchuck, chuck, and woodchuck, good chuck, chuck. And so this is where we're calling the OpenAI's API. This is where we're using the Twilio's API. This is where we're using other Twilio's API. And the cool part about these APIs is I don't own this server. I did not have to buy this server. I don't have to have a sysadmin running the server. I don't have to worry about the electricity of the server. I don't have to worry about the CPU fans of the server. Basically, these are just APIs that I'm connecting to that I pay X amount of money to be able to interact with. Now, again, the important thing with those APIs, again, it goes back to this, where, again, this was for SendGrid. So SendGrid allows you to send and receive emails. And so these are the languages that SendGrid is able to communicate with. Again, so Python became very popular somewhere around 2010. So PHP was like the language for a lot of people up until about 2010, and then Python took over. One of the reasons that Python took over is because PHP was very good for infrastructure that you owned. You owned the MySQL server, you owned the email server, you owned the data store. PHP worked with that really nicely. Here's the thing, in 2010, again, the service-oriented architecture, that started to be the cool thing. And so all the cool kids, and again, this is how it works, this is how it works in the real world, right? All the cool kids didn't want to deal with some old, nasty PHP language. And so when they built their APIs, generally the APIs back then were built for Python. If you wanted to be able to communicate with their systems, the only way to do it was to use Python. And that was one of the big drivers for Python, 10 some odd years ago, is simply because all these APIs with this really cool functionality came out. The only way to communicate with the APIs is if you use Python, ergo, you use Python. Again, all this stuff is really paint by numbers. Like there's this idea in the tech world where there's these geniuses. There's these geniuses that are reinventing everything. They're like, how should the world be? The reality is we're really just doing paint by numbers. we're just doing paint by numbers. It's like what color should be here? Oh, yeah, that color. You see the finished paint. You see the finished painting, and you're like, wow, look at that amazing artist. You don't see all the geeks sitting there with the paint by numbers. Okay, the blue goes there. Okay, green goes there. That's what we really do. Anyways, the final thing for the day to talk about is Waterfall versus Agile project management. And Agile, the true disaster of the modern world. When you hear the differences between these two. So this is something to consider. Oh, Agile, how you have made our lives so much worse. So there's different project management styles. You will hear about different project management styles. I'm old school. I'm old school. Like back in the days when we actually researched and figured out what problems we were trying to solve and figured out what resources we had and then built a solution. Anyways, there's different ways of doing project management, especially in the modern world. So when we talk about waterfall, there's a waterfall project management style. Basically what this is you basically go out with your team, however many people you have, and you figure out what the hell you're doing. Ooh. Oh God, I do get snarky. It's true snark though, it's true snark. Anyway, so with what's called waterfall, so you go out to all the vested interests. And when we talk about vested interest is anybody who has a significant interest in how your project will work. So this could be the investors. It could be the CEOs. Stop worrying about them so much. They can take care of themselves. Really what this is going to be is it's going to be the warehouse workers, and it's going to be the secretaries, and it's going to be the installers, and it's going to be your minimum wage employees. Right? And basically you go out and you talk with the vested interest, right? So you go to the CEO. Basically you go to the CEO and the question is, why the hell am I here? What are you trying to accomplish? And basically they say, we need to ship more widgets, right? We've talked with the board, and the board agrees that we need to ship more widgets to make our company be more successful. Fine, whatever. Or they may say, we need to increase profitability. I guess it's not that. We need to increase profitability. So that might mean taking out some of these employees or whatever, or maybe increasing the value of the product that's being sold. Or they may say these people need to talk more together. Again, I don't know, you talk with the CEO, they're going to have a dozen different things, right? So basically you talk with the CEO, say, hey, what is the overall problem that we're trying to solve for? Again, then you figure out who the vested interests are. Generally, the CEO is the least of your interest. This is the ass you kiss the most, and also the one you listen least to. You really want to listen to these people so that your project isn't a damn disaster. And you go to them, and you ask them how the system is currently functioning. What do they like about the current system? What do they dislike about the current system? What are the quirks of the system? And again, you go talk to everybody. Talk everything with the warehouse worker to the help desk employee. Talk with everybody to figure out, right? And so you start getting an idea. It's like, okay, so this is the problem that we're trying to solve. These are the good things that they currently like about the system. These are the problems that they currently have with the system. Then you go back to somebody like the CTO, and you say, okay, so what's the legacy look like? What is our legacy infrastructure? And that's where they say, most likely we're on the Microsoft stack. Right? Okay, so do you plan to get off the Microsoft stack anytime soon? Hell no. Okay, so you're on the Microsoft stack. So you're dealing with Microsoft legacy and whatever else that stack looks like. And so you start taking a look at this and you're like, okay, so what is your time frame? What is your time frame? How long until this product needs to be deployed? And they tell you 3 hours, because that's what they do. They give you a stupid number. They give you like 3 months or 3 years or whatever else. So you can start planning for how long this whole project is supposed to take. And then you ask them how much money are they going to pay you and how much resources are they going to give. And again, money and resources are two different things. There's the money that you want to take home. But then there's also resources, right? They may have piles of servers sitting in a warehouse somewhere that they don't necessarily need to rebuy. It's like, oh, we have 20 Xeon servers that have been collecting dust for the past 3 years, so feel free to use those. Again, that's a valuable resource, even if it is a specific cache. And so you get the idea of what is the problem to solve, what do the vested interests care about, what does a legacy infrastructure look like, how much are they going to pay you, how much resources are they going to provide, what is your time frame, and a whole bunch of other things, right? And then once you have that, you sit down, you design your project, you go back and forth to validate, everything looks pretty good, and then you build the project. The idea here with a waterfall project management style, more or less, is essentially you design the finished product, and then you build the finished product. And then you do some tweaks. There's an issue with this though. Again, it's humans, it's people. Oh, people suck. People suck. I like people, but it's hard sometimes. It's hard. People will tell you the stupidest crap in the world. People will lie to you. There was a show back in the day called House. And basically the big thing that he always said is that people lie. By God, it's true. They just lie for stupid reasons. They just say stupid crap, right? So you'll go and you'll interview the vested interest. You'll be nice, right? You'll take the secretaries and the warehouse workers out for cups of coffee. You'll sit there with your thing and you'll write down every damn thing they tell you. And you do what you're supposed to be as a good person. And then you find out after you build the entire damn project that, oh no, they didn't care about anything that they said. What they really cared about was something entirely different. And the problem is with the waterfall style is basically you design the project and then you build to that design, and then when users do what users always do at the end of the day, right? That can be a bit of a disaster. So the idea with Agile, project management style, is build quickly and iterate. So the idea, you go to the CEO, you ask questions, what problems are they trying to solve? You go to the CTO, what legacy are they dealing with? And then you basically ask them, how much money are you going to pay me on a monthly basis? This is beautiful. You think subscription services suck. This is awesome. And then basically what you do is you sit there with your little team and you code, an initial product, something like a minimum viable product. And this is trying to solve some of the problems. This takes some account for the users. And basically you send this minimum viable product out into the world as quickly as possible so users can start screaming at you and telling you how stupid you are for building such a crappy product. Right? You get that advice back, and then you build the next iteration of the product and you ship it out. And then you get the advice back and you build the next iteration back, get the next iteration back, next iteration back, next iteration. And I know you're probably sitting here like, well, Eli, okay, well that's interesting. So when does this process stop? When I decide to retire? I figure about the time I can afford a 100-foot yacht is about when this stops. And then basically though, that's the idea with Agile, is you create the product as quickly as possible, you send it out to the users, you get the feedback, you iterate. But again, one of the things I always point out to you folks, right, if you do not define what a win is, nor do you define what a loss is before you start a project, how do you know when you're done one way or the other? How do you know when you've succeeded? Or frankly, how do you know when you failed if you haven't properly defined the outcome? And this is a huge freaking issue we get in the tech world, where basically you have this project management style that never ends. And I've seen this be a disaster with companies, where companies have spent hundreds and hundreds and hundreds of thousands of dollars in order to build their application. And then basically they're like, okay, we spent $500,000. We feel pretty good for ourselves. So when's the development gonna stop? And then you have the development company say, what do you mean? And then you have the CEO go, what do you mean? And it's like, well, we'll stop the main development, but this process never really stops. So we can decrease from a $200,000 a month burn rate down to, I don't know, let's say a $20,000 per month burn rate, but you're still paying us $240 a year. Oh, and we built all of this, so if you try to hand this over to another development company, yeah, that's probably going to be a bit of a disaster too. So this is what Agile is, and yeah, evil incarnate is what I would describe it. So, but it's one of those things that you have to think about, and one of the questions you have to think about for yourself as a coder or as a business owner or whatever else is, where is the end going to be? where is the defined end that you're trying to get to, or you're just going to keep developing this thing for absolute ever. And so that's a basic class on introduction to programming. So giving you the idea of what programming is, the stacks, all of those kinds of things. Final thing, I guess there wasn't a note there for it. We talk about IDEs. These are called integrated development environments. So this is VS Code. This is the IDE that we use for Silicon Dojo. And basically what an IDE is it's simply the place where you write your code. So a lot of this code, like Python and PHP and stuff, you can actually write in a text editor. Back in the day, I used to use Notepad to write PHP code, right? Because IDEs used to cost money. VS Code is basically free. The cool thing with things like VS Code is, since it is a piece of software, you can add extensions. That's deprecated. Anyways, you can add extensions to allow really cool things with VS Code. You can allow for this to be able to connect up to things like GitHub or your servers or that type of deal. And basically, again, it's that whole thing of you can write a term paper on QuickBooks, but it's probably not a great idea. The same thing is true. You can write code in Notepad, but it's probably not a great idea. Essentially, all an IDE is it is an environment where you're able to write code, and it gives you the specific tools that make writing code and deploying code a hell of a lot easier. There are a lot of different IDEs out there. The thing I like about VS Code is everybody I know uses VS Code. So I get this question from a lot of students. They're like, hey, can I use a different IDE? It's like, I guess you can. Everybody I know uses VS Code. This is, again, Microsoft product. Awesome Microsoft product. Microsoft gives us away for free. There's no licensing. You can just use it. And it's just kind of one of those default standards. The thing that I'll tell you is if you decide to use different IDEs, it's kind of like going between Word to Google Docs to Pages to LibreOffice, right? All of those are word processors, but they all do slightly different things. They all look slightly differently and interact differently. It's going to be the same thing with IDEs. So again, especially when we do troubleshooting, so when we do office hours or whatever, if you want me to take a look at your code, if you pull up your code in VS Code, the colors and the errors that pop up, I'm going to know what the hell those are by just looking at them. So it'll be easier to do things like troubleshoot or audit your code. Whereas if you use, was it PyCharm? I don't know, if you use one of these other IDEs, it just literally is it's more difficult. It's like, what does that squiggly mark mean? Why is that purple, right? So anyways, that's one of the things to think about with IDEs. That's all an IDE is. It's the place where you're going to be writing your code. And so that is a class. That is the introduction to programming class. I will turn all of this, as soon as I get done with Python, the Python series, I will turn this into a self-study series. So all of these will get broken out into their own classes. But at the rate that I'm going, that will probably be here in February or something. So, questions? Anybody got any questions? No questions? Hands up. Let's see here. Jennifer, unmute. Yes, Jennifer.
Can you hear me?
Yep.
Is there a charge for the excuse me? Is there a charge for an office visit?
Oh, no, it's free.
Okay, thanks.
Yeah, so everything that I'm trying to do here, and again, we'll see how it works out in 2 years. DonorBox, have you seen DonorBox? What I'd like to do, again, with this, morals, politics, whatever else, what if we actually believed that, humans were valuable, right? If we empowered people, it made the world a better place. That's kind of the idea here. And so what I'm trying to do with Silicon Dojo is the concept of can we figure out a way to abstract out the education component from the financial component? Because especially doing YouTube videos, doing YouTube education, the people I have been run into have been so touching, and it's been amazing. Like I ran into a guy here in Asheville, It was 11 o'clock at night. This black guy walks up to me. He's like, "Oh my God." I'm like, yeah, I'm Eli, the computer guy. He says, "No, you don't understand." I'm like, what don't I understand? He said, "Look, I'm from Africa." And he was like, my village didn't have an internet connection. I used to walk to a village with an internet connection to download your videos, to watch them, and now he's in a university in Cincinnati. I met another guy actually here, ironically, in Asheville. He was from India. And he said he was from just a backwater village in India and used my classes, and he now works at Cisco. Or he worked at Cisco, there's been some layoffs, who knows. And so like that's one amazing thing, like having done this for 15 years and having actually talked with the people that the education has really changed their lives, again, it comes to that question of, what if we actually pretended that people were valuable? Yeah. Anyways, so I'm trying to make Silicon Dojo free to the end user. Again, it is a fever dream, so if I don't get enough donor box donations, we'll see how that works out in a couple of years. Oh, Vladimir, I saw you had your hand up. Still have a question, Vladimir?
No question. I just wanted to say thanks so much for this wonderful class.
No, yep, no problem. Oh, let's see here. Yep, if anybody has questions, put your hands up. I'll look through comments. What do you like better, 2-week sprints or 1-month sprints? Yeah, so when I did coding professionally, we still weren't in that time period. A lot of that is like new methodology. We just used to build stuff. We were just locked in our own little rooms and we built things. And we came together every once in a while. So yeah, I don't know. Whatever sprint length you want. So that's what the Agile, so you'll hear about things like Scrum sessions and sprints and all that kind of stuff. Those are words. I need to get up to date on all these words. And basically it's how you go about, it's the process you go about with the project management cycle. So yeah. Let's see here. I feel like shorter sprints turn into more meetings. Maybe. So can I send you an email with a specific question that is not related to this topic so that I don't sound like an idiot on this recording? Oh, come on now. It's fun to sound like an idiot. I don't know. You send me emails, I may or may not get back to you. I don't work well with emails. Again, I'm an Aspie. There's just certain things like brains just don't do well with. Like written communication. I just suck at, and I won't lie to you. I'm not gonna like polish the turd. Like I will get emails from people, and I'll be like, oh, I really need to respond to them, and I'll put a little flag on it, and it'll be there. And every day for like 2 months, it'll be there when I log into my computer. And then after 2 months, I'll be like, fuck it, and then I'll just archive it. So yeah, email don't really work very well. We do have the forum, if you want to ask questions on the forum. So again, I am trying to get everybody to use Silicon Dojo. That's the whole point of this. There is forum here. You can ask a question on the forum. Or you can do the one-on-one, if the forum will show up. Or you can do the one-on-one meeting with me or whatever else. Again, it's not you, and I'm not trying to be snarky about the emails. I just don't do it. I literally am mean to it. It's kind of like being a guy. Like you mean to send Christmas cards every year. I mean to send Christmas cards, and then my wife tells me the Christmas cards have already been sent because it's like a week before the Christmas. Just one of those things. Oh, let's see here. If you have questions, raise your hand. I have no mic, bummer for my desktop. I found Eli while flashing a Cisco Wi-Fi. I want to know what is the future of programming in the next 2 years with all that AI doing programming. Yeah, don't stop. Fuck me, stop, people. Look, one, it's not AI. It's not intelligent. They're LLMs. God bless them. They're great. They're good for what they are, but they're not AI. Look, the technology world changes. Like, I think one of the things that I find adorable about the younger generation is to realize how long things have actually been relatively static. So there's this idea that technology is changing at the speed of light. And here's the deal, it was. a decade ago. But like when I went in the army, so I went in the army in '96. The MOS, so the job specialty I was in electronics, it had previously been 132-week MOS training and 129-week MOS training. For my generation, they were both combined into one 33-week MOS training. A year after, another entire MOS got sandwiched on, and they basically kept doing that. So even back in the 90s, there is rapid change in technology and what you were supposed to support. I got my MCSE and NT 4.0, basically for sysadmin certification in 2000. Literally, one frickin' month after I get my MCSE, they're already talking about the MCSE for 2000, the next iteration. And then as I finish the boot camp for 2000, they're already talking about the 2003, right? MCSE. And so technology changes. And again, when I started, there used to be this thing called TechNet subscription, where you would get CDs of Microsoft's white papers. You pay $450 a year, and you would get CDs for troubleshooting and all that. There are books of CDs. There would be an index CD. So if you have a question, you type it into the index CD, and then it would tell you what CDs to pull out of your collection, and then go to those and find whatever it is that you were looking for. And then we got Google and all that kind of stuff. And so the thing to be thinking about is that technology is always changing. Technology is always changing. And so as a technology professional, you just simply need to always be looking out for what the next things that are going on in technology are, and then kind of shift your course to wherever that is. Again, understand, for any Americans out there, right, any American programmers, your job died 20 years ago, right? American programmers became obsolete in 2005, obviously. Right? After 2005, I mean, come on, an American programmer making more than somebody at McDonald's? That's ridiculous. And you're like, what the hell are you talking about? Right? Because you've heard about all these programmers, all these kids making $250,000 a year. What do you mean programming became worthless? There is this idea, and again, this is weird. I'm not that old. I don't feel that old. I guess I'm almost 50. Fuck me, am I the only one that's been awake this entire time? Anyways, back in 2000, there's something called the Y2K issue. There's this thing with clocks. Anyways, with Y2K, it was a really, really boring problem to solve. Basically, a whole bunch of software code had to be opened up, and a whole bunch of people had to tweak, basically, variable values. Right? It was really boring. None of the cool kids wanted to do it. We had these things called fiber optic. We had T1 lines back then. And so basically, companies realized they could send their code all the way to India. They could have Indians modify these stupid little bits of code for $5 an hour and send it back, and all the problems were solved. And then they realized, well, hell, if we can pay Indians to solve Y2K issues for $5 an hour, I wonder what other problems they could solve. And so there was this idea, and there was a book called The World is Flat. And if you ever want to just really laugh, go back and find books from 20 years ago on popular economics or whatever, and see how they thought the future was going to go, and then see how it didn't go. And so the idea back then, is the world being flat, is that if we have fiber optic lines that are going all around the world, then basically the jobs obviously will end up going to the most qualified employees that are least expensive. Ergo, jobs such as coding, which only rely on a computer and a brain, right, and a T1 connection essentially, coding jobs will just naturally all go to India, and the coding profession in the United States will die. This is what we were told in 2005. Oh, too bad. You got into coding too late. Obviously, nobody can have a job anymore. That did not exactly work out how a lot of people thought it was going to work out, right? The same thing is true with AI, LLMs. The same thing is true with large language models or multimodal models and these types of things. Will it change things? Yes. Is it going to kill tech jobs? It's going to change tech jobs, right? Things are going to move on. Again, being a full stack developer, again, where you have front end developers now and back end developers, and like being a full stack developer is going to be a hell of a lot easier now. And so again, things are simply going to transition. If you focus on solving problems, if you focus on solving the most valuable problems that you can find, that people are willing to spend money for, you will continue to have a job for a long, long time. If you're like, I know React, I should make 200 grand a year because I know React, it's going to be miserable for you. Right? Again, like nobody cries over the telephone system administrators. So that's where I talk about, again, so I had 100 hours in certification for what are called Definity systems, long gone. High-level telephone system administrators back in the early 2000s, they were making quarter mil a year, $250 a year, again, 20 some odd years ago. And so those were what are called analog and digital telephone systems. And basically, voice over IP came in the early 2000s. And it's insane. Like the uptake of VoIP was ridiculous. Like within a couple of years, VoIP went from nothing to 50% of the market, just owning the market. And so you had these telephone system administrators that went from making $250,000 a year to literally being worthless. There was no step down. There's no step down process. There was no lateral transition. It wasn't like if you knew telephone, if you knew Definity, you could go do Cisco. Cisco is an entirely different world than Definity. Have some funny stories on that. But that's the thing, like things change. And so if you're willing as a telephone system administrator to go and get your CCNA and then work your way back up on the network stack, right? You'll be fine in 4 or 5 years. If you're just like, telephones are my life, well, yeah. So anyways. Let's see here. AI has helped me from being an IT person who can't program to an IT person who can make good enough spaghetti. Yeah, that's kind of how it goes. And again, again, AI, LLMs, let's call them LLMs, large language models, multimodal models. Again, they're going to be force multipliers. It's going to allow one person to be able to do more work. But again, there's that question, will it take jobs away? I would argue interest rates are going to take the jobs away. But when using those API services, is the configuration one time or every time the configuration changed from the owners of the service? So when you do an API call, so we've had classes on REST API calls. So the idea with the API, so when you're dealing with API, right? So you got your box and you're communicating with OpenAI. This is all supposed to be standards. So again, nobody wants to reinvent the wheel. So basically, OpenAI is going to come up with a set of standards for how you're supposed to communicate with their server. And then they're also going to have a set of standards for when the data comes back, what that data is supposed to look like. So if you use REST APIs use something called JSON. We've had a couple of classes on JSON, JavaScript, object notation. I don't know, it's JSON, we won't get into it. So anyways, so some APIs will send back a JSON response, and it should be formatted the same way every time, right? Because you're going to do response, square bracket, blah, like whatever the value name is. And so in order for you to be able to get back that value, it has to be the same every time. Again, different APIs are going to interact differently. So when we use OpenAI, so we've had classes on OpenAI, and OpenAI about a year ago changed their response format. So again, it is the API vendor who gets to decide how this crap works, right? So OpenAI used to, when I started doing OpenAI classes 2 years ago, they used to send back a JSON response. They now send back a class response. What does that mean? So basically with classes, we haven't talked about classes yet, but anyways, so with JSON, right? JSON right? You will do like response, square bracket 0, square bracket, let's say city. And what this would do is from the first record, it will give you the name of the city, which is Asheville. And so you use square brackets. So anything that would relate to a list is a numbered index, 0, 1 through whatever else. Anything that would relate to a dictionary will be a named index, city, ISP, a name of something. So anyway, so that's what a JSON response would look like. OpenAI changed your response to be a class-based response. And so now the response looks like, it looks more like something you get out of JavaScript. So it'd be like response 0.city. And so, yeah, anyways, so this is a 0 record. City is, what the hell is that called? Is it the attribute? Anyways, city is the value there, so it looks different. Again, more of that is, much of that is neither here nor there. The big thing to be thinking about is essentially OpenAI is going to determine what that response looks like, and then you have to parse the response based off of how it looks, but it should be relatively stable. Because again, remember, like OpenAI is making a lot of money off of this API call, so if they break crap, if they start breaking everybody's responses, people are just going to go over to Claude. Again, remember, they're a business. They're a business. So if they run their business in such a fashion where I'm having to fix my code, or I'm having to change my code every week, I'm going to find a different damn vendor. So more or less, it should stay the same. Though OpenAI did change, I say, a year and a half ago or something. Oh, let's see. For the tech industry in 2025, is it better to be a generalist or a specialist? Better know a little about everything than everything about nothing, or master one trade rather than dabble in 10. To be good in the tech field, whether it's 1995 or 05 or 15 or 2025, what you need to do, and this is going to be hard, it's going to be so hard. You need to go talk to your damn boss. Again, it's frustrating in this modern world. Like, again, we got this whole idea of like the 99% versus the 1%. Unfortunately, especially in the United States, our education system is so bad. People don't quite understand how small the 1% is. People think everybody's the 1%. The 1% is literally 1% of the population. And they're not all your enemies either. But anyways, one of the big problems we have is that, there's this whole idea of bosses are mean to employees and what bosses need to do. Anyways, one of the things you need to think about doing is, it's going to be controversial. I'm going to say something. You're going to cancel my ass. You're going to put this on TikTok, my career is going to be over. You need to treat your boss like a human. What? Yeah. You need to treat your boss as if they're like actually a person. And then you need to go have a conversation with that person about what would make their life better. Hey, boss, how could I help make your job better? And then they will tell you what it is that they care about. And again, what that is, I don't know. Again, you might need a troubleshooter. Again, like the generalist, what I was, generalist, I was told to go fix it. I would walk into server rooms. Nobody even knew what the damn boxes did. I was just told to fix it. I fixed it, right? So again, you might be a troubleshooter. You think about this with, like a lot of IoT stuff, right? So if you're going to go work for a company that has a lot of IoT products, so Internet of Things, basically these devices, they go out into the world and they do what the hell ever. So I think about this like with solar installation. So one of my clients was a solar installer. And so some of my work was literally going to solar installations because they didn't know how to deal with a little freaking communication box. So I had to go and get this damn thing configured to be able to communicate with 4G or whatever back in the day in order to get the solar panels to be able to send data off to their things. And so that's the thing, like depending on the company you're working with, like a troubleshooter, right, may need to be a generalist so that you understand a lot about many different types of technology to a rather narrow degree. On the other hand, you might be working in a company, right? They need people to get really deep in the weeds about specific things. Or again, like I say, it's the industry, what it is you're looking at. So what you really need to do is you need to go out, you need to talk with your boss, or you need to talk to people that are in your profession, who are in the physical area where you want a job, which is now weird with the whole remote work thing. But anyways, going to meetups, again, creating relationships with people, talking with people, and literally saying, hey, out of curiosity, this is where I am at in my career. You know, if you were in my position, where do you think the most valuable thing to go for? And then go for that. Because again, like so much of the technology world, it's about where you happen to be. If people are deploying a particular technology in your area, right, then if you know that technology, you get a job. If you don't know that technology, you don't get a job. So that's really what you need to do. You need to go talk to people. It's true. Get some money, start buying some people some coffee. Throw those $5 bills on the counter as you buy lots and lots and lots and lots of people coffee and ask them what their opinion is. Oh, let's see here. You can raise your hand. I don't have to do all of this through chat. Anyways, that debate has been a family debate and colleague debate for years and years. Yes. Your job is to make your boss look good. Well, your job is to try to let your boss keep their sanity. Again, that's one of those things I always find funny when people complain about their bosses. And again, feel free to complain about your boss, but maybe calm down a little bit. Like the last time I had employees, it was interesting. Hilarious is the word? Probably hilarious is not the word. Anyways, so one day I walk in, and I'm trying to keep my sanity. I'm trying to keep my fucking sanity. Because my wife was dealing with breast cancer. Right? So she had thyroid cancer, gone through the whole thyroid cancer treatment, literally got the okay for the thyroid cancer treatment. Shit you not, it was like 2 months later, gets diagnosed with breast cancer, gets double mastectomy, fucking shit show. Anyways, so I'm going in and I'm dealing with my employees. And one of my employees, he just complained about everything. He complained about fucking everything, bitched about everything. Fuck me. If my wife hadn't been going through cancers, I would have fired his ass in a heartbeat. The problem is when your wife is going through all these cancers, you don't necessarily have time to hire a new employee and get them up to speed, which is like one of those wonky. Anyway, so I was talking with one of my employees at the time, and I was talking about the whole cancer thing, and I remember him looking at me and being like, oh wow, when did she have cancer? And I literally looked at him and was like, what the fuck are you talking about? I'm talking about the goddamn appointment I went to yesterday. It's like, oh, like, yeah, when I'm coming in here bitching at you guys to fucking complete your goddamn work orders and call the fucking customer every goddamn day, yeah, after I get done bitching at you, I get to go home and fucking help my wife deal with a double mastectomy. So maybe a little less fucking whining and just do the job you were hired for. But anyways, again, do you know if your boss's kid has a drug problem? Do you know if your boss's spouse has a mental health problem? Do you know what stage of cancer your boss's parent is currently in? So anyways, having employees that come in and say, hey boss, hey look, I've got some extra time, I'm trying to move up in my career, what is it that would make all this a little bit better for you? I swear to you, employees that do that will make it further. But anyways, that's my own PTSD talking. Oh, let's see here. Oh... So, yeah. So about your friend that needs C# programmers, is that a sure thing? I don't know, it was a sure thing a couple years ago. Go to Baltimore. Find him. His name's Ed. Go to some meetups. Say, are you Ed? Hey, Ed. I heard you need C# developers. Go talk to Ed. Don't. Again, you all need to create your own relationships. Oh, let's see here. Oh, so anyways, okay. So that's it. Any more questions? Any more questions? Actual questions? Hands up. No hands up. Okay, there are no hands up. So silicondojo.com. Again, you can come to the forum. You can ask questions here. We actually do have a system for loyalty points. There's even a point system. So if you ask questions, you may or may not get loyalty points at this point. I don't know. But you can ask questions here. I will try to answer you. I try to focus on this. Like, okay, if there's one place I have to answer things, it's on this. So forum is here. Again, if you go to home, if home comes up, Wix is a little bit slow, I gotta say. The only complaint about Wix. Come on, go home. There we go. Again, like I said, we got the office hours now. You can just sign up for them. We are going to have the self-study program. So this is the old self-study program for Python. This was going to get swapped out. So this is there. It's just more of a show you how it works. And the video for today's class will go onto the YouTube channel, and it also gets posted here. And if you want to come to the virtual box for virtualization, you can RSVP. And if you RSVP on Silicon Dojo, then we get to track you. Again, that's all we're going to do. It. What was that? There was some kind of weird ass, there was like a hand thing that went up. I don't know what the hell that was. Okay. So that's it. No other questions? Been fun. See you all next week. Virtual box, show you how to install Linux into a virtual machine. See y'all later.